So, today we're going to start section 1.3, which is solving linear equations. So, there it is. At the top of your note sheet, I said write down the 4 reminders. Here are the 4 reminders. The first reminder is the golden rule of algebra. Just like the golden rule of life is do unto others as you want unto you. And the golden rule of algebra is what you do on one side of the equal sign, you gotta do to the other side. You're adding, make sure you gotta stay in balance. It's all about staying in balance. Second reminder, if you're going to move something to the other side, you got to do the opposite. So if it is being added, you need to subtract it from both sides. If it's being multiplied, you need to divide it on both sides. If it's being divided, you need to multiply it on both sides. If it's being squared, you need to square root it. Third one, you ain't done until you got number equals variable or variable equals number. If you've got 3x equals 7, sorry, you're still not done yet. Yes, you have the x term by itself, but I want x all by itself. And lastly, whenever and wherever, please check your answer. You should know, if I were to give you a test today, or tomorrow, or any day, you should know fairly close whether or not what your grade is. Whether or not you're right or you're wrong. If you're checking your answers, and I'm not talking you have to go through an extensive check. Checking your answers might take you 20 seconds. Put your answer back in, check it out, make sure it works out. You know if you're right or not. It's just me. If I'm thinking that I could either just go blindly on faith, or I could check my answer and know for a fact that I've got that nailed it, well, I'm going to nail that thing. Okay? Hammer time. Okay? So, what I would like you to do now is, we'll do these 2 by 2, so we'll do these first 2. So, I'm going to pause the video here. You work on these first 2 examples, and then we'll come back and we'll do those, and then we'll... So, on this one, I would probably subtract 9 from both sides. That then gives me negative 4x equals, what would that be, negative 32? Then I would divide both sides by negative 4, and that would leave me with x equals positive 8. Doing a quick check, I would say 4 times 8 is 32. 9 minus 32 is negative 23. So it checks out. Second one, I would, now, because you guys have done math once or twice or 3 straight years, I would think that you would be able to add x to both sides and add 3 to both sides all at the same time. Okay? If that's too much going on for you, do them individual. But if you think you can handle it, I think you can handle it. So that leaves me here with 8x equals 18. Then I would divide both sides by 8, and that would leave me with x equals 9/4 when I reduce that one. Okay? Now, as an FYI, I am a fractions kind of a guy. Okay? I much more prefer 9/4 as opposed to 2.25. Okay? All right? Cleaner, neater, nicer. We're seniors. We don't have to be scared of fractions anymore. Okay? 63/4 minus 12/4, that's going to be 51/4. 9, 60, 51/4. Both sides equal 51/4. Yep, so it checks out. Okay? So let's, there we go. Try the next 3. Now, just because I'm a fractions guy doesn't mean we have to deal with them all the time. Okay? So I'm going to do C and D in 2 different fashions. Okay? And there's a little tweak to both of them, but in the end you would get to the same destination. Okay? So in C here, what I'm first going to do is I'm going to clear everything but the fraction. So I'm going to subtract 9 from both sides, which then leaves me with negative 4/5 x, and that's going to equal negative 41. Okay? Then I can divide both sides by negative 4/5. Okay? So I could divide over here by negative 4/5, which is the same as multiplying by negative 5/4. Okay? Dividing by a fraction is the same as multiplying by its reciprocal, which allows me then to get x here equals positive 205/4. So that's 41. 9 minus 41 is negative 32. Yep, checks out. Okay. Now, in D, one other way to do is, if you're not a big fan of fractions, and not many people are, I get it, okay? But what you can do is, from the start, get rid of the fractions. So I'm going to multiply this entire equation, in this case, by 15. Okay? It's the least common denominator. I'm going to multiply everything by 15. So 2, so this 15 has to go into there, and into there. So 2 times 15 is 30. 30 divided by 3 is 10 times x is 10x. 3 times 15 is 45. Divided by 5 is 9 minus 9x equals 60. Okay. So by multiplying by that LCD, you get rid of this case, it actually works out to where it's just x here equals 60. Okay? And you get 40 minus 36, which is 4, and 4 is equal to 4. So.
Are you just distributing to the numerators, right?
Well, yes, just to the numerator. Don't put it into the numerator and denominator. Yeah, because it really is. So here it would be, the math that I was doing was 2/3 times 15 over 1. Because if I go 15 times 15 over 15 there, then that's not changing anything because that's multiplied by 1. Okay? Good? RG, good back there? Okay. I didn't know if you were questioning or flipping the hair. Okay. Decimals, done exactly the same. Subtract 0.5. That leaves me with 0.6 G equals 2.4. Divide by 0.6. That leaves me with G is equal to 4. And that one checks out also. Questions on that? Couple of special situations here. If I distribute here on this first one, then I get 5x minus 20 equals 5x plus 12. Okay. If I subtract 5x from both sides and add 20 to both sides, then I get 0 over here equals 32 over there. What's wrong with this scenario? What? What's wrong with this scenario? 0 doesn't equal 32. That's a false statement, and I don't have any variables. Okay? So the first thing you should do is go back and make an honest look at your work to make sure that you did your work right. Okay? Yep, did our work right. Okay? If that still is the case, if nothing changed then, if this is a false statement, with no variables, then your answer is no solution. Now, if you want to put no sol, S-O-L, that's fine. That's a no solution. I'm guessing you can figure out what this one's going to be. Actually, here, let's do this. Let's be smart about this. So this side combines to be that. Right? And then if I subtract 10 and add 5x, I get again, no variables. But what's the difference in this one? this is a true statement. And in that case, then, it is in all real numbers. If you use the symbol, or if you write out the words, all real numbers, either one works. Word problems. Try them. Try them. And you will see. It jumped ahead a page. There it goes. All right. So, does anybody know, and you probably, some of you might have even done it, does anybody know the biggest mistake that people make when doing a word problem? No? Say loud. Not actually reading the problem. Okay? Biggest mistake that people make when doing a word problem is not reading it. Now, that may seem like, how can you do a word problem without reading it? And you'd be surprised. Okay? Okay? So, always make sure you take that time to read those problems. Okay? John rents a sailboat on vacation. The boat has a rental fee of $45 plus a $7 per hour fee. If John is charged $101, how many hours does he rent the sailboat for? Okay? So you are looking here for how many hours John rents the sailboat. Okay? So we're looking for hours. Okay? Now, my question to you is, can this answer be a decimal? Can it? Yes. Okay. Could it be a fraction? Yes. Could it be negative? No. Okay. So right away, you've taken of your infinite amount of answers, you've just cut them in half. Okay. Just by not even starting the problem yet. Okay. You know that then if you got a negative answer here, you're wrong. Okay. Logic helps. Okay. So, boat has a rental fee of $45. So, right off the start, he's going to spend $45 to rent that boat. Plus $7 per hour. And he got charged $101. Okay. So, we can subtract 45 from both sides. Oh, so what is that, 56? Divide that by 7. So that gives me x here equals 8, right? 8 hours, yes, okay? Word problems with the exception of if it were just like if we would have said, you know, the first number is this and the second number is this kind of a deal. But if there's labels in your word problem, there should be labels in your answer. So the answer here is 8 hours. For sure. Faux show. Okay. Salesperson at an electronics store has a base salary of $10,000 per year and earns a 15% commission on total sales. How much must the salesperson sell to earn $25,000 in 1 year? So X here is now going to be total sales, because that's how much what we're looking for. How much must the person sell? Okay, so base salary of 10,000 and earns a 15%, so that's going to be 0.15x, and we want that to be $25,000. Okay. So we can subtract off 10,000. That'll leave me with 0.15x equals 15,000. Then I'm going to divide both sides by 0.15. And that's going to leave me with x here equaling 100,000, right? Right? 100,000? And then the label would be dollars. Yep. Okay? Kind of jumped around. It looks like it's a lot, but it's really not. Okay? It's just because I didn't want you to have to do a lot of repetition on a bunch of problems. So it only ends up being 4, 10, 18 total problems. And you got until Monday to get it done. Okay? It's also at the bottom, if you're writing it down, it's at the bottom of your think sheet too. Okay? They're back there. I see them. They're behind that black crate. Okay? And then once again, just a reminder, there is no formative tomorrow.